Morning. Also in last class we were looking at this result. So let script A be an algebra of subsets and sequence AI is a sequence of sets in script A. Then we need to show that there is a sequence BI of sets in script A such that Bn intersection Bm is equal to phi for n not equal to m, and when you take the union from I equal to 1 to infinity Bi, that is same as a union I equal to 1 to infinity Ai. Now the result is trivial for when you have a finite number of sets. So we have seen that in last class. Say if we are having the sets A1, A2 and A3, then we'll take B1 equal to A1 and B2 we can take as A2 minus A1 edukka and take B3 equal to A3 minus A1 union A2. So this will give us the required disjoint set. So this will be A1. So നമുക്ക് B1 എന്ന് പറയുന്ന first set കിട്ടി. Then you take A2 minus A1. So this will be the second set B2. Then take A3 minus A1 union A2. That will be the third set. So you can see that the union of all these three will be A1 union A2 union A3, and when you take the intersection of each, they are going to be disjoint. So this is how we take it for the finite case. Now we need to show the same for infinite case. So let us see the proof. Again, നമ്മൾ അവിടെ bns choose ചെയ്യുന്ന ഇതേ രീതിയിൽ തന്നെയാണ്. So we'll show that it will work for any n. So for any value of n, we'll show that union I equal to 1 to infinity. Bi is equal to union I equal to 1 to infinity Ai. So let us see the proof. So the result is trivial. Then sequence AI is finite. Now we'll prove the case for the infinite case. So we assume that sequence AI is an infinite sequence. And let us set B1 equal to A1, and for each natural number n greater than 1. So let us define, take Bn as an minus an minus, so that's the symbol we are going to use. So a1 union a2 union etc. an minus 1. Now by using so this is a symmetric difference of the sets, so that will be equal to an intersection a1 a minus b nu parayna, that will be a intersection b complement. So here you will get an intersection this is a1 union a2 union a n minus 1 whole complement. So that will be an intersection. So this will be a1 complement intersection a2 complement intersection an minus 1 complement by De Morgan's law. So that is all of them are intersections. So that will be an intersection a1 complement intersection a2 complement intersection a n minus 1 complement. So this is going to be bn. Now as we know, since A is an algebra, so we know that algebra will be closed under unions and complementation, and by De Morgan's law we have seen that it is closed under intersection also. So here you have intersections and complementations. So we can see that this set an intersection a1 complement intersection etc an minus 1 complement, that is again going to belong to script A. So each bn will be contained in script A. So since complements and intersections of sets of script A are in script A, we have, so bn will belong to script A, and also നമുക്ക് bn എന്ന് പറയുന്നത് bn will be an intersection a1 complement intersection etc an minus 1 complement. So you can see that an intersection ഈ സെറ്റ് ആണ് വരുന്നത്. So bn will be automatically a subset of an. So each bn will be contained in a. Now we need to show that bn intersection bm, where n is not equal to m, that must be equal to 5. So let us take bn and bm. So let bn and bm be two sets such that, so let me take m less than n. So automatically bm എന്ന് പറയുന്നത്, so by this for every n, each bn will be contained in an. So bm will be contained in am. Now let us take bn. So let us take bm intersection bn. So bn intersection bm. So since bm is contained in am, so this will be contained in bn intersection am. Now this will be equal to am intersection, and as we know bn will be an intersection a1 complement intersection a2 complement intersection a n minus 1 complement. Now we know that since m is less than n, so one of the terms in, so one of the terms in the intersection will be, so you will have am complement in this intersection. m less than n ആയതുകൊണ്ട് m less than ആ n വരുന്ന എല്ലാം ഇവിടെ വരുന്നുണ്ട്. So there will be am complement in this. So this can be written as am intersection am complement intersection the remaining. Now if this comes, so automatically this will be equal to 5. So we can say that bn intersection bm is contained in 5. So this happen only if bn intersection bm is equal to 5. So therefore bn and bm are disjoint sets. Now we need to show that union I equal to 1 to infinity bi is equal to union I equal to 1 to infinity bm. അതായത് നമ്മൾ if you take x containing in one of the unions, we must show that x belongs to the other. So we must show in both ways. Okay, so let us show that union of bi's is equal to union of ai's. As we know each bi is contained in ai. Now since each bi is contained in ai for all I, so union I equal to 1 to infinity bi will be contained in union I equal to 1 to infinity ai. Now if you can show that union I equal to 1 to infinity ai is contained in union I equal to 1 to infinity bi, so both will be equal. So let us take x belongs to union I equal to 1 to infinity AI. So we'll show that X is also contained in union BI. So union AI will be contained in union BI. So combining both the results, we can say that the unions are equal. So if X belongs to union I equal to 1 to infinity AI, then X must belong to at least one of the AIs. X union element ആണ്, so X must belong to one of the AIs for some particular I. ഇനി X ഒന്നിൽ കൂടുതൽ സെറ്റിന്റെ contained ആവാം. So let us take n to be the smallest of all such suffixes where x is contained. So x can be contained in say some an, a, n plus 2 etc. അങ്ങനെ പല സെറ്റ്സിൽ കണ്ടെയ്ൻഡ് ആയിരിക്കാം. അപ്പോൾ let us take n to be the smallest of all such values. So then x must belong to at least one of the AIs, and let n be the smallest of such I, so that x belongs to I. So x belongs to AI. So n is the smallest of all such i's. Therefore, x belongs to an. Then x also belongs to bn equal to, so bn we have taken to be an intersection a1 complement intersection a2 complement intersection an complement. ഇനി നമ്മൾ ഇവിടെ എടുത്തിരിക്കുന്നത് x belongs to an where n is the smallest of all such i's. Okay, അപ്പോൾ നമ്മുടെ x എന്ന് പറയുന്നത് a, so x does not belong to a1 a2 etc. a n minus 1 x ഉണ്ടാവില്ല, പക്ഷേ it will be contained in a1 complement. a1 ഇല്ല, അതുകൊണ്ട് അത് a1 complement ഡെഫിനറ്റ് ആയിട്ടുണ്ടാവും, a2 complement ഉണ്ടാവും, an minus 1 complement ഉണ്ടാവും. അതുപോലെ we have taken x belongs to a n. So we can see that so we can actually write it as, so x belongs to an, then x will belong to an intersection a1 complement intersection a2 complement intersection a n minus 1 complement. This is because x belongs to an, and since x does not belong to a1 a2 a1 a2 an minus 1, so that implies x belongs to a1 complement a2 complement etc. a n minus 1 complement. Now this implies x belongs to, so this is the definition for bn. So x bn ആണെങ്കിൽ, so x will also belong to union I equal to 1 to infinity bn. So therefore for every x belongs to union, so we started with x belonging to union I equal to 1 to infinity ai, then x will belong to union I equal to 1 to infinity bi. So that implies union I equal to 1 to infinity ai is contained in union I equal to 1 to infinity bi. So we have already proved that union I equal to 1 to infinity bi is contained in ai. So combining both, you can actually show that union I equal to 1 to infinity ai is equal to union I equal to 1 to infinity bi. So this completes the proof of the